Question 4, we have to simplify this. So that means we have to collect any like terms that we have, and our final answer should be in terms of I. We know that this is going to happen because we're taking square root of negative numbers. Now we know that I is equal to the square root of -1. So what we will try and do is rewrite each of these terms so that we have a square root of -1, and then we will replace the square root of -1 with I. Now to do that, it's very simple. Each of these negative terms under the square root, sorry, this is supposed to be a -81. So each of these negative numbers under the square root, I can rewrite them as a product of whatever number there is and -1. So I have square root of -1 times 16. This one is 4. There's no negative, so I leave it as it is. And then minus square root of -1 times 9 minus 3 plus square root of -1 times 81. Now here you notice I've not changed anything because -1 times 16 is -16. So I have negative square root of 16 under the square root. Same thing there and there. So what I do is I can separate this like this. So -1 times square root of 16 plus square root of 4 minus the square root of -1 times the square root of 9 minus 3 plus the square root of -1 times the square root of 81. Now this is possible to do because I have a product. It's one of the laws of indices that says that if you have a plus b to the power of m, sorry, a times b, I'm getting confused. This is equal to a to the power of m times b to the power of m. So this is a law of indices. If you have a product raised to an exponent, you can always separate the exponent. And square root, we know, is an exponent. It's to the power of half. So this one over here, I can work out. We said square root of -1 is just equal to I. Square root of 16 we know is 4. So I have 4 times I. Then I have 4I. Plus the square root of 4, which is 2, and then I have minus this minus over here, and then this is I times 3, this is 3I, and then minus 3, and then this is I, so this is I times square root of 81, which is 9I. Then from here, very simple, I just count how many i's do I have and how much do the real numbers add up to. Okay, so I have 4i minus 3i, that's I, and then plus 9i, this is 10i. And then I have 2 minus 3, this is minus 1. And that is my final answer. I hope you can see that. Okay, next one. We have to work out this division. Remember, when we're dividing complex numbers, the way we do it is by multiplying by the conjugate of the denominator. And we say to get the conjugate of the denominator, this is just 2 plus I over 2 plus I. The difference between what I have over here and the denominator is the sign of the imaginary part. The imaginary part is the coefficient of I, so that's the only difference. And this is 2 plus I over 2 plus I. This is equal to 1. When I multiply any number by 1, it doesn't change. It is exactly the same. So me multiplying this fraction by this, which is equal to 1, does not change its value. It remains the same. And you know how to multiply fractions: numerator times numerator, denominator times denominator. So the 3 will multiply the 2, I get 6. The 3 will multiply the I get 3I. The negative I will multiply the 2, this is negative 2I. And then the negative I will multiply the I get negative I squared. Then I do the same thing in the denominator. 2 times 2 is 4. 2 times I, this is 2I. Negative 1 times 2i, this is negative 2i, and then negative I times positive I, this is negative I squared. Then I collect my like terms. Remember, this is a real number. I squared is -1, negative of -1 is +1. So I have 6 plus 1, which is 7. And then here 3i minus 2i, this is just positive I. And then in my denominator, we say this is a real term. I squared is equal to -1. So if I squared is equal to -1, then negative I squared is negative of -1. This is equal to 1. So that's where I get it from. Okay, so I have 4 plus 1, which is 5, and these two, you can see they cancel each other out. So I have 2i minus 2i, this is just equal to 0. So that's what I have. Then just leaving it in the form a plus b, this is equal to 7 over 5 plus 1 over 5i. So we always like to leave it in that form, a plus bi. So this is not the same, I'm just saying this is not the same as 7 over 5 plus I. No. Okay, so this is definitely wrong. Do not write it like that. Okay, so here you can see my denominators are the same, and when I add them, I'm back over there. But this one here, if I were to add these two, I would have to make this 5 over 5, and then I will get 7 plus 5i over 5, which is not what I have over there. Okay, so to work this one out, the easiest and most straightforward way to do this is the first fraction, you multiply it by its conjugate, the conjugate of the denominator by itself, and then write it in the form a plus b, and then add it to this one. You can combine them at once. Change the denominator here, it's 1. You change it to 1 plus I. You can do that, that is fine. Combine them and then do the division by multiplying by the conjugate of the denominator. There's nothing wrong with that if you do it correctly, but that seems like a very long way to go. So the shorter way, I think, to do it is multiply this fraction by the conjugate of the denominator. So I have 4 minus 2i over 1 plus I times 1 minus over 1 minus I plus 2 minus 5i. Okay, so notice again the difference between a complex number and its conjugate is the sign of the imaginary part. So here it's positive, there it's negative, and then we do our multiplication as usual. So 4, can you see it? Okay, so I have 4 times 1, I get 4, and then 4 times minus I, this is minus 4i, and then minus 2i times 1, this is minus 2i, and then here negative 2i times negative I. Negative and negative gives me a positive, and then 2i times I, this is 2i squared. Okay, then in the denominator, 1 times 1 is 1, 1 times minus I, this is minus I times 1, this is positive I, and then I times minus I, this is negative I squared, and then I still have to add this term over there. Okay, so this is what you have. Then we can simplify this. Now here I have 2 plus, I have 2i squared. Remember that I squared is equal to minus 1. So when I multiply minus 1 with 2, I get negative 2, which I can combine with this one over there. So what I should have over here, this is equal to, let me see if we can, okay, I think that's better. So I will have negative 2 being subtracted or being added to 4. So I will have 2. Okay, and then these two combine to give minus 6i, and then in my denominator these two will cancel, and then negative I squared, we say I squared is negative 1, negative of negative 1, so this is negative I squared. This is same as negative of negative 1, so this is equal to I squared, so this is just equal to 1. So I have 1 plus 1, which is 2, and then I have to add the 2 minus 5i. Now here I can rewrite this as 1 minus 3i plus 2 minus 5i. So I say 2 divided by 2 is 1, 6i divided by 2 is 3. Now here I just collect my like terms. I have 1 plus 2, this is 3, and then minus 3i minus 5i, this is minus 8i, and then that is my final answer. The next one is a multiplication of two complex numbers, minus 2 over 3 minus I, and then minus 1 over 6 minus 2i. Now this one, we know how to multiply complex numbers. So this is number 3. Let me just label it. So this times that. When you multiply them, negative and negative, your answer will be positive. When you multiply them, the answer is 1 over 9. So technically it's 2 over 18, but 2 over 18 is the same as 1 over 9. And then the same thing, this one times that one. Again, it's a negative times a negative, so my answer is positive. So I will get 4 over 3i. And then here again, negative times negative is positive, so I get 1 over 6i. And then negative and negative again gives me a positive value, so I get 2i squared. So this is what you have when you multiply everything out. So again, this 2i squared that we saw in the previous question, 2i squared is equal to negative 2. So I have negative 2 plus 1 over 9. This should give me negative 17 over 9. You can check that out on your calculator, but you should be able to do it without your calculator. And then I have 4 over 3 plus 1 over 6. This is just equal to 3 over 2i. The last part of number 4 is we have to add those two complex numbers. So BODMAS still applies even with complex numbers. We need to work out what is in the brackets first. So I work this out, get my answer, and then I'll add it to that one over there. So I need to remove the brackets over here. So I have 5 minus 4i plus negative 6 plus I minus 3 minus 5i. Okay, so when I remove the brackets, that's what I have. Okay, so inside this bracket I can simplify. I have negative 6 minus 3. This will give me negative 9. And then I minus 5i. This is minus 4i. And then I need to add my answer to this over there. Okay, so because this is an addition, I can just remove the brackets. It doesn't change anything. So I'll just say 5 minus 9, which is 5 plus negative 9. This is negative 4. And then minus 4i plus negative 4i. This is negative 8i. So that is our addition of those complex numbers.